So these are the Mod 4 Part 5 notes. This is page 3. We're going to use something called the empirical rule. It's also called the standard deviation rule. Okay. And we are looking at that bell-shaped data, that normal distribution. We like this because certain things happen, no matter the data set, provided that it is normally distributed. So we get this bell shape. Okay? So our mean always in the middle of that distribution. And then we can count out by standard deviations. So, and we're going to do an example of this and put numbers to it in a minute. If I go one standard deviation above the mean, I know that I will hit approximately 34% of my population. 34% of my population lives in that space between the mean and one standard deviation above. When we go to it's the same if we go below. Again, here's the symmetry. 34% of the population will live in that space between the mean and one standard deviation below. Symmetric, so same above and below. I can go to 2 standard deviations. I trap another 13.5%. So 2 standard deviations below, and this 13.5% is between my 1 standard deviation and my 2 standard deviation values. So if I take a look at the mean to 2 standard deviations above, I am looking at this 34 plus 13.5%, I get 47.5%. Okay. And then 47.5% from the mean to 2 standard deviations below. Our final chunk here is that 3 standard deviations above. We capture another 2.35% of the population. And then we leave out in our tails above 3 standard deviations from the mean or below 0.15% of the population. Okay. Here is our empirical rule. The percentage of data within 1 standard deviation is approximately, good to work with, 68%. Roughly 2/3 of our population, if we're talking about height, if we're talking about shoe size, if we're talking about IQ scores, is within 1 standard deviation of the mean. We can capture approximately 95% within 2 standard deviations of the mean, and then approximately 99.7% within 3 standard deviations. And these are the accepted values here. And you see that empirical rule stated again below. Okay. So I'll highlight this for you so you can find it. And then let's talk about how we're using this. Example 5, the intelligence quotient, our IQ. Data is normally distributed with a mean of 100. So my mean of 100 goes right here in the middle. Standard deviation of 15. So 1 standard deviation above, 100 plus 15 takes me to 115. 2 standard deviations above, 115 plus another 15 gets us to 130. And then 3 standard deviations above, 130 plus 15 gets me to 145. Okay? Remember that we still have parts of the population with an IQ higher than 145, but that is 0.15% of the population. So we're going to do the same thing below. 100 minus 1 standard deviation. I get 85 minus another standard deviation, and I am at 70. And 3 standard deviations below the mean, I'm here at 55. I am going to go ahead and color code to what we had before. So from my mean to 1 standard deviation above is 34% of the population. From my mean to 1 standard deviation below, again, is 34% of the population. Between 1 and 2, I capture another 13.5%, and it's symmetric, so it works that way on both sides. And then my very last little bit here between 2 and 3 is 2.35% of the population. That captures 99.7%, which means outside I have 0.15% that have an IQ of greater than 145, and 0.15% of the population that has an IQ less than 55. Okay? So I'm going to use that, and actually what I'm going to do is something that's a whole lot easier when I'm electronic, and I am just going to copy and paste this to the bottom of the next page. Oh, rude. Let's try that one more time. I should be able to paste the whole picture, I thought. We'll go with duplicate, see if that works. Oh. No, okay, we'll just refer to it up there. So we want to know what percent of the population, and let's see if we can color code here. What percent of the population has an IQ between 85 and 115? So my 85 to 115 is right here. That's the 34% plus 34%, and again, 68% of our population lies within 1 standard deviation of the mean. Between 70 and 100, so here I am, 70 to 100. My 70 to 85 is 13.5%. My 85 to 100 is 35% of the population. I get 47.5% of the population between 70 and 100. Between 85 and 130. So here's my 85 to 130. 85 and 100 is 34. 100 to 115 is another 34. And then between 115 and 130, I have 13.5% of the population. I end up with 81.5% of the population. See how long before I run out of colors. We got between 55 and 115. So here's my 55 to 115. 55 to 70 is 2.35%. 70 to 80 is 13.5%. Sorry, that was to 85. 85 to 100 is 34. 100 to 115 is 34. When I add these together, I get 81.85%. Below 100, I did that wrong. So below 100, I'm going to go up here. This half of the population, remember that 100 is our mean. It divides our population in half. So 50% of the population lies below 100. And you can also add those numbers together and just double check. What percent of the population has an IQ above 100? So now we're looking at the other half of the population. Again, our mean divides our population in half. So 50% of the population has an IQ above 100. What percent of the population has an IQ below 85? So below 85 is this right here. I got a 0.15 plus 2.35 plus 13.5. I get 16% of the population has an IQ below 85. And then we are going to go the other direction. What percent of the population has an IQ above 85? This is going to be everything else. So the entire area under the curve has to add to 1 or 100%. That's our entire population. So I can take the 100, subtract the 16 that we just had, and we have 84% of our population with an IQ above 85.